what we're going to look at is how to apply tangents. Now, when it comes to applying tangents, it is a trigonometry function, so we have to remember our little acronym to see which sides go with which trig function. So we have SOHCAHTOA. So sine is equal to the opposite side over the hypotenuse. We have ka for cosine and toa for tangent. So cosine is adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent side. And we can use this last one when we're talking about things like angle of elevation or angle of depression. Now, what those are is, if I take a look at this nice little diagram, we have person A, person B. Both of them have that horizontal line of sight. So person A being up top of the stairs, we got this horizontal line of sight looking down at person B. The angle created by that line of sight horizontally and down at person B is known as the angle of depression. Whereas person B, the angle created between his horizontal line of sight up to person A is known as the angle of elevation. And we can use these in order to figure out heights or distances depending on what information we are given. Such as in this first problem, we have Scott, whose eye level is 1.5 meters above the ground, 30 meters from a tree. Angle of elevation to the bird at the top of a tree is 36 degrees. How far above the ground is the bird? Round to the nearest hundredth. So we got 2 decimal places to round to. So first things first, we're going to mark up this picture a little bit. We are told that we have a angle of elevation of 36 degrees. So angle of elevation means I got this horizontal line of sight, and we're looking up at the bird at the top of our tree. So the angle created between the horizontal line of sight and the bird is 36 degrees. We're also told that we are 30 meters from the tree. So there's our distance from the person to the tree. The other piece of information we are told is the height from the ground to the line of sight is 1.5 meters. So the only thing we really have to figure out here is how far is the bird to the line of sight. So that section is our unknown x. So if I take a look at the relationship between our known sides here, our x and 30 meters compared to our 36 degree angle, x is across, so it's opposite, and then 30 meters would be the adjacent side. So opposite and adjacent means we are dealing with tangent, and tangent of our angle 36 degrees is equal to the opposite side, in this case it's x, over the adjacent side 30. So to figure out what x is, all we need to do is to get x by itself. So anytime there's a fraction, I like to get rid of it, and we do it by multiplying by the denominator. In this case, it's 30. So both sides will get multiplied times 30. So what that does is the 30s will cancel out on the right-hand side of the equation, leaving us with just x equals, and then all I have to do is 30 times tangent of 36. So anytime our calculator's on, make sure we're in the proper mode. We're in degree mode, so we're good. And we just have to do 30 times the tangent of 36. And we get 21.79627.584. Our instructions were to round to the nearest hundredth, so 2 decimal places. So 799 is the second, so I take a look at the number next to it, 6. 6 will round the 9 up to a 10, which actually turns the 7 into an 8. So we have 21.8 meters. So this means from the bird to the line of sight is 21.8 meters. Now we have to the question was, how far above the ground is the bird from the ground? So this part is 21.8, but the line of sight down to the ground is 1.5. So we actually have to add the two of these things together. So 21.8 plus 1.5 gives me 23.3 meters. So the bird happens to be 23.3 meters from the ground. So this is using tangent in order to figure out unknowns and applying it where we have to do a couple additional things. So in this case, we had to draw angle of elevation, assign numbers and unknowns, and at the end we had to add to get our final answer. And that's what we're going to be dealing with today, stuff that is a little more involved. Now this one, our second problem here, we have an angle of depression of 40 degrees. John is watching his friend approach his building while he's standing on the rooftop. Rooftop is 16 meters from the ground, and John's eye level is about 1.8 meters from the rooftop. How far is John's friend from the building to the nearest tenth? So again, we have to do some markups. So John's friend down here to the building is our unknown. There's our x. We're told the ground to the rooftop is 16 meters. And we are told John's eye level is about 1.8 meters from the rooftop. So from the ground to John's eyesight, the full way down is going to be 17.8 meters. So I'll put that there just in case we need it. Now, angle of depression, again, is when I have a horizontal line of sight looking down at something. So in this case, we're told the angle of depression is 40 degrees. So the angle that's created by this line of sight and then down at John's friend there is going to be 40 degrees. So here we have our unknown x, height of, in our case, 17.8 meters up to John. The question becomes, what is the angles that we're dealing with here? So it doesn't really give us any hint about what's going on down here by John's friend. However, I do know that a horizontal line of sight connected with the vertical part of the building is going to make a 90-degree angle. So if this part is 40 degrees, then that means the other part of this angle has to add to 90 degrees. So 40 plus what gives me 90? Well, that means 50 degrees. So here we have our angle 50 degrees, sides x, and in our case, 17.8 meters. So we have an opposite side and an adjacent side. So we're going to use tangent again. So tangent of our angle that we're working with, in this case it's 50, is equal to our opposite side, x, over our adjacent side, 17.8. And just like the previous problem, we're going to multiply by the denominator to get rid of it. And we do it on both sides, 17.8. This will cancel out on the side with x. So we just have x equals, and then we just have to multiply 17.8 times the tangent of 50. And we end up with 21.2 meters after we round. So John's friend is 21.2 meters from the building. Now number 3 is a little bit different. It's a word problem. We don't have any image to go with it. So what is the problem that we have here? We got a person on the deck of a lighthouse, sees a ship with an angle of depression of 20 degrees. Lighthouse is 28 meters tall, sitting on a cliff that is 45 meters tall as measured from sea level. What is the horizontal distance between the lighthouse and the ship? Round to the nearest meter. So first things first, I want to draw this picture. So we have a cliff at sea level, and we know that the cliff itself is 45 meters tall. We are also told that we have this lighthouse sitting on the cliff. So lighthouses are always over here. And we got a nice little beacon shining of the light with this person standing on the deck. Wrapping around the thing. Now, we are told that we have a angle of depression. So this means if this person is looking out horizontally, this means the angle he's looking down at is 20 degrees. So 20 degrees all the way down. So angle of depression there is 20 degrees. And the boat is down there on the water. And we need to figure out how far this boat is from the lighthouse. So lighthouse again, so cliff is 45, lighthouse is 28 meters tall. So how far are we? Well, here is our unknown. From here on over to the boat is our unknown side x. We do know the height from here to the top of the lighthouse is just like before, where it is 45 and 28. So from the top, we have 73 meters from top to bottom. Now, just like in the previous problem, we have horizontal line, angle of depression 20 degrees, which means the other part here created is a 70 degree angle. So again, creates a 90 degree angle, that part's 20, so that means the other part is 70 degrees. Now, what we have to do is use tangent to figure out just how far we are from the lighthouse. So opposite from our angle is x and the adjacent is 73. So tangent of our angle we're working with is 70 is equal to our unknown side x over 73. And to get x by itself, we multiply both sides by 73. This will cancel out, giving us just x equals, and then we can do 73 times the tangent of 70. And we get 200.5, we round up to 201. So in this case, the boat is 201 meters away from the lighthouse. And again, a little more involved where we had to draw a picture and label everything. Now we can also apply tangents on the coordinate plane. So we're told lines N and M, if we have these two, we have an angle of depression of 36 degrees between the two. We have to find the slope of the line. Well, again, slope of a line is rise over run. Now, we read a graph left to right just like a book. So rise, the up and down part is always first. So left to right, my line is going down. So in this case, my line M is the one that is going down. So it's going to be negative M over our run N. So that's what we're looking for, the negative value of M over N. So I take a look at 36 degrees. I see that M is the opposite side, N would be the adjacent side. So we can actually say tangent of 36 is equal to M over N. So first thing, all I got to do is take the tangent of 36 degrees. So tangent 36. So that means 0.7265. So again, round to 4 decimal places. 4, we're going to keep it as 5. So 0.7265. And that is equal to M over N. But I need negative M over N. So all I have to do is change this from positive 0.7265 to negative 0.7265. So that would be the slope in terms of our coordinate plane here. Now, number 5, line makes an angle of depression of 24 degrees. We got to find the slope of the line to the 4 decimal places. So, unlike before, so just like before, all we really have to do is take the tangent of what we have. So, tangent of 24. And we get 0.4452. Now, what we have going on here is we are actually going down left to right, so all we got to do is make it negative. So negative 0.4452 would be the slope to 4 decimal places. Now, let's say we got something a little bit different. We got Samuel at the top of this tower riding a trolley down a zip line to the lower tower. So he's up here on the top in the higher tower, and he wants to go to the lower tower. Total vertical drop of the zip line is 40 feet. And the angle of elevation from the lower tower is 11.5. What is the horizontal distance between the two towers? Now, basically, from here to here is what we're trying to find our unknown. However, it does give us a few clues about where we're going to be working. So, we are told the angle of elevation from the lower tower to the top tower is 11.5. Now, we're not starting down here. We're starting up here. We're starting up here at the top of the smaller tower. So, the angle of elevation is actually going to be from the top of the tower, the smaller tower, to the top of the bigger tower. So notice the distance is still the same, whether it's the bottom line here that I labeled X or whether it's up here. It's still value of X. We are also told the vertical drop from the top of the tower to the lower tower is 40 feet. So from here down to here is 40 feet. And then our angle that they told us is 11.5 degrees. So, not 11.5 squared, 11.5 degrees. So, what we need to do is we need to figure out the value of X. So, again, we take a look at what we have. We have an angle, we have a side and an unknown side. So, we can look at the relationship between our sides. So, 40 is across or opposite 11.5. X is our adjacent side. So opposite and adjacent means we're working with tangent. So tangent of our angle, 11.5, is equal to the opposite, 40, over our unknown, X. So what we have to do is solve for X. Now again, we have a fraction, which means to get rid of it, we multiply by the denominator, X. And we do it on both sides. So this will cancel out, and it leaves us with X times the tangent of 11.5 equals 40. And the last thing I need to do to get X by itself is I'm going to divide by the tangent of 11.5. And I do that to both sides. And it's going to cancel out on the side where we're dividing it by itself, leaving us with X. And then what we have to do is divide 40 by the tangent of 11.5. And we get 196.6, round to the nearest foot, so 197. So the horizontal distance between the two towers ends up being 197 feet. And then this last problem here, number 7, find to the nearest foot a height of a tree casting a 24-foot shadow when the angle of elevation of the sun is 52 degrees. So again, just like problem number 3, we don't have a picture. We have to draw a picture ourselves so we kind of know what's going on. So We have the sun, and we have a tree, and then we're casting a shadow on the ground. So we know the shadow itself, according to our problem, is 24 feet. What we have to figure out is the height of the tree. So from here to there is our unknown x. Now we do know that the angle of elevation to the sun is 52 degrees. So when we draw the line up, we have a 52 degree angle of elevation. So all we have to do is use what we know to figure out our unknown. So here is our angle. Side x is across from it, so there's our opposite. 24 feet is our adjacent. So we can use tangent of our angle, 52 degrees, equals our opposite side, x, over the adjacent side, 24. And to figure out what x is, we just multiply by the denominator to get rid of the fraction on both sides. That will cancel out, leaving us with just x. And then 24 times the tangent of 52 gives us 30.7 feet. And again, round to the nearest foot, so 30.7, we round to 31. So the height of the tree ends up being 31 feet. And again, this is applying picture, making pictures, applying tangent, using unknowns, and solving for x within word problems dealing with tangent.